Hello everyone, I welcome all of you to SST College of Arts and Commerce. This is SST Edupedia. Myself Krishna Salgaonkar. I am an assistant professor in ITCS department. Today I am going to talk about data structure course, which is a part of SYIT semester 3 syllabus, and the topic is Introduction to Data Structure. This is the first unit of your syllabus. What are the things we are going to see today are introduction to data structure, then classification and operations on data structures, preliminaries of an algorithm and algorithm analysis and complexity. So first let's start with introduction. A data structure is a way of sorting data in a computer so that it can be used efficiently and it will allow the most efficient algorithm to be used. A data structure should be seen as a logical concept that must address two fundamentals. There are two fundamental concerns with a data structure. The first one is how the data will be stored, and second, how operations will be performed on it. So in short, if I want to tell you about data structure, is storing data in a computer. If you are storing the data, then there must be some purpose. The purpose of the storing data or data structure is we have to allow so that most efficient algorithm can use that data, or we can say that operations will be performed on that data. So basic two main fundamental concerns: storing the data so that we can perform some operation on that data. Now it starts with classification of data structure. First we have to understand how these data structures are classified. So they are classified as simple data structure, compound data structure, linear data structure and non-linear data structure. So there are four classifications: simple, compound, linear and non-linear. Let's see. So if I have to show it diagrammatically, you can see like this. Data structure is divided into two: simple data structure and compound data structure, and then compound data structure is divided into two: linear data structure and non-linear data structure. So stack, queues, lists are under linear data structure, and non-linear data structures are trees and graphs. Now let's start with simple and compound data structure. Simple data structure can be constructed with the help of primitive data structure. A primitive data structure used to represent the standard data types of any one of the computer language. Variable, arrays, pointers, structures, union, etc. are example of primitive data structure. So when we talk about simple data structure, we should know about primitive data structure. In any programming language, these primitive data structures are variables, arrays, pointers, structures, unions. These are the various things we use to store the data. Then there is a compound data structure. Compound data structure can be constructed with the help of any one of the primitive data structure, and it is having a specific functionality. It can be designed by a user. It can be classified as linear data structure or non-linear data structure. So basic idea that it is constructed with the help of the primitive data structure and it is having specific functionality. Again, it is divided into linear data structure and non-linear data structure. Linear data, now we will see what is a linear data structure and non-linear data structure. Linear data structure can be constructed as a continuous arrangement of data element in the memory. It is a continuous arrangement of the data element in the memory. It can be constructed by using array data type. Example, if we construct array, then we can call it as a linear data structure. In the linear data structure, the relationship of the adjacency is maintained between the data elements. Non-linear data structure, of course the name suggests non-linear. Non-linear data be constructed as a collection of structure can randomly distributed set of data items joined together. So randomly distributed set of data items are joined together by using a special pointer tag in the non-linear data structure. For the relationship of adjacency is not maintained between the data items. So here the relationship between adjacent data types are not maintained, and we can call it as a randomly distributed set of data items joined together. So basically we have four types of data structure. The earlier one which we have seen is simple data structure and compound data structure, and under compound data structure we have linear data structure and non-linear data structure. Now after that we will proceed towards operations on data structure. So these are the various operations which are performed on the data structure: add an element, delete an element, traverse, sort the list of elements, search for a data element. So these are the basic operations which are performed on any data structure. So when we have a data, sorted data, we can add an element in that, or we can delete the element in that, or we can traverse that, we can go through that data, then sort the list of elements, sorting we can do, or search a particular element. Now this is another concept, that is abstract data type. And abstract data type, sometimes abbreviated ADT, is a logical description of how we view the data and the operations that are allowed without regard to how they will be implemented. So this is basically how we view the data and the operations that are allowed without regard to how they will be implemented. We just view, we are not bothered about how the data or the operations are implemented. By providing this level of abstraction, we are creating an encapsulation around the data. So when we provide this level of abstraction, basically abstraction means hiding. So we are least bothered about how the things will be implemented. We just see how the data and operations are allowed, and this abstraction creates an encapsulation around the data. The idea is that by encapsulating the details of the implementation, we are hiding them from the user view. This is called information hiding. So through this encapsulating, we are hiding them from the user's view, and this is called as information hiding. Now let's start with the next concept in data structure, that is algorithm. This is very important. Now first we have to understand what is meant by a algorithm. An algorithm may be defined as a finite sequence of instructions, each of which has a clear meaning and can be performed with a finite amount of efforts in a finite length of time. So basically algorithm is for solving the problem. We are writing the algorithm for solving a problem. It gives you the logic to solve that problem. It's a sequence of instruction which has clear meaning and finite amount of effort in a finite length of time. Means you can complete the algorithm at some stipulated period of time. So this is what we can call as an algorithm. The word algorithm originates from the Arabic word algorithm, which is linked to the name of the Arabic mathematician Al-Khwarizmi. Al-Khwarizmi is considered to be the first algorithm designer for adding numbers. So this Khwarizmi is considered to be the first person who designed the algorithm for adding the numbers, and he is a Arabic mathematician. Now once we understand what is an algorithm, so algorithm are the steps to solve a problem. Now we will try to understand how to structure an algorithm, how to write an algorithm. So what are the steps? So first is input step, then assignment step, decision step, repetition step, and then the output step. This step may change the sequence, but basic are you have to write some input step, then you have to assign some value to that input, then we have to perform some operations or decision or repetitive steps, and then we have to display the output. Now let's start with properties of an algorithm. There are many properties related with the algorithm, but out of that I mentioned some few of the properties. The first one is finiteness. An algorithm must terminate after finite number of steps. So when you are writing any algorithm, you have to take care that it should end after some finite number of steps. Then definiteness. The steps of algorithm must be precisely defined. All the steps in the algorithm must be precisely defined. Then generality. An algorithm must be generic enough to solve all problems of a particular class. For a particular class, it must solve all the problems. And the last one is effectiveness. The operations of algorithm must be basic enough to put down on pencil and paper. So these are the four properties, that is finiteness, definiteness, generality and effectiveness. One more thing is there, input and output. The algorithm must have certain initial and precise input and output that may be generated both at its intermediate and final steps. So you may take the input in the intermediate or the final steps. Now this is what is more important, that is algorithm analysis and complexity. What is mean by algorithm analysis? For same problem statement we may have number of algorithms. So suppose if you are to do searching, there will be 10 algorithms to perform the searching. So you have to decide which one is the best for your set of data, and that is called as algorithm analysis. So we will just go through the algorithm analysis and complexity. The performance of an algorithm can be measured on the scale of time and space. Whenever we have to calculate we have to analyze the algorithms. So if I have 5 algorithms, I have to analyze on the different parameters. So here what we use is a time and space. So first is time complexity and second one is space complexity. Time complexity of an algorithm or a program is a function of the running time of the algorithm or a program. So it's a function of time required to solve that problem. And space complexity of an algorithm or a program is a function of the space needed by the algorithm or a program to run to completion. So space is like the size of the data. So the functions of the space needed by the algorithm or a program to run to the completion is called as space complexity. Algorithm analysis and complexity. The time complexity of an algorithm can be computed either by an empirical or posterior testing and theoretical or a priori approaching. The empirical or posterior testing approach calls for implementing the complete algorithm and execute them on a computer for various instances of problem, and theoretical or a priori approach call for mathematically determining the resources such as time and space needed by the algorithm as a function of parameter related to the instance of problem considered. So we are going to use the theoretical approach and not the empirical approach. Here we are going to concentrate more on the theoretical approach. So here we are going to calculate on the base of time and space needed. So for this, the asymptotic notations are used. The first notation is big O notation. So we can call f of n is big O of g of n. If there exists a positive integer n0 and a positive number c such that f of n is smaller than and equal to C and G of n for all n greater than or equal to n of n0. So basically now this big O notations gives you the upper bound of a function. So when we upper bound of the time required, so whatever time required to solve that algorithm, the upper bound, maximum time bound, we will get with this big O notation. So when the function f of n is smaller than or equal to C into G of n for all n greater than or equal to 0 and C must be greater than 1, that time we can call as a big O notation exists. Then there is omega notation. It gives the lower bound. Now initially it is a upper bound, now it is a lower bound. So f of n, so if we check, f of n is greater than or equal to C into G of n for all n greater than and equal to n0. Here f of n is greater than C into G of n, so it gives you the lower bound. So basically big O notation is a upper bound and omega notation is the lower bound, and the last notation is theta notation. It is the average, so you get the average between upper and lower bound. So f of n is called as f of n is equal to theta of G of n. So when it exists, when there is a positive integer n0 and two positive constants c1 and c2 such that c1 into G of n is smaller than and equal to f of n and is smaller than and equal to c2 into G of n. So if the f of n lies between these two bounds, that is the average, so it gives you both the upper and lower bound. So that time we can call as a theta notation. Now this is the diagrammatically it is shown the upper bounds and lower bounds of a particular function. If we plot the graph, then O notations graph will go up, omega goes down, and theta gives you both upper and lower bound. So in this we initially try to understand what is the data structure. We have seen the types of data structure. Then we try to understand what is the algorithm, what is the complexity of algorithm, and how to decide, how to analysis, how to do the analysis of the algorithm. And for that analysis, we should know how to calculate the time, and that is based on this notation. So there are three notations: big O notation, omega notation, and theta notation. I hope you understand all these things. Thank you, everyone.